Hello friends, today we are going to learn the second last chapter, that is DC to DC converter. Okay, so as name indicates, DC to DC converter is a converter which convert one DC into another DC. Then what is the difference? Difference is it converts a fixed DC input, probably fixed DC input voltage, to a variable DC output voltage. Are you getting? Sometimes the DC input voltage can also be variable, but mostly the fixed DC input it converts into a variable DC output voltage. Okay, so where it is used, it used mainly in trolley cars, then marine hoists, then forklifts. Trucks means which used in an industry to lift material, and mine haulers. Then it is expected that in the future electric automobiles, everywhere, wherever there is a speed control and braking is expected, people will use DC to DC converter. Okay, what is the advantage of DC to DC converter? Its advantage is it offers a smooth control, high efficiency, fast response, and regeneration. The most used devices are SCR, Power BGT, Power MOSFET, or IGBT. Okay. Now, in DC to DC converter, we can say it is having, actually it is not having types, but one can differentiate into AC link chopper and DC chopper. DC chopper means where DC input is given and we got a DC output. Okay, means variable. And AC link chopper means we give DC to inverter. Okay, we invert it to AC, then that AC is given to the rectifier to vary the output, and then it converted it into DC. So the system is bulky, but it is used and it is called as a AC link chopper. Okay, so we'll start one by one. So in DC to DC converter, if you read carefully, you can see the terms like step up chopper, step down chopper, okay, step up, step down chopper. Okay, these are some terminologies. At the same time, there is a buck converter, boost converter, buck boost converter. Okay, so one can get confused between what is the difference between step down chopper and buck converter, because buck means also step down. So let me clear, it is one and same. The only thing is when we say step down chopper, it may not have control with the output. But when I say buck converter, then after this inductor, there should be one feedback path. Here should be some control strategy, and that is given to the as a gate pulse to the as a control to the switch. Okay, so output will be checked or it is compared with some reference signal, and accordingly the firing angle is varied or width of a pulse is varied, and we get output. That is the difference. So if in exam, if step down chopper is asked, you can draw this. If buck converter is asked, then also you can draw it. It is exactly right. If you want, you can show the feedback signal like that. Otherwise also it is okay. Okay, so to start with a step down chopper. What is step down chopper? As the name indicates, its output voltage V0 is less than input voltage Vs. Okay, so you can see there's a switch. You can use any switch like a MOSFET, IGBT, SCR. Then there is a diode, freewheeling diode, inductor, and load. How it works? So when switch is on, that time supply will start from this through switch, through inductor. It will give supply to the load. Okay, this is how it is working. For a voltage, you will get a complete voltage during on period. For a current, as inductor is there, it will oppose a sudden change in current, and current will rises gradually like this. Slowly, it will reach to the peak. Now, at after T on, switch is made off. Okay, so now switch is off during this T off. Now, how for what time switch is to made on and for what time it is to be made off, it dependent on what average output voltage we require. Okay, so now when switch is off, that time inductor will oppose a sudden change in current, as I said. So it will develop a voltage L di by dt across it, and it will maintain a direction of current through it. But now as switch is open, it will complete its path through this freewheeling diode. Okay, so stored energy in an inductor is now getting dissipated. Means it is getting released to the load. Okay, so till here inductor was charged. Now inductor will get discharged like this till here. Okay, before reaching to zero, it is continuous conduction mode. If there is a resistance, then obviously that is not the case. It will be discontinuous conduction mode. But as it is a inductive load, So now from hereafter again switch is made on. So again your output voltage will start increasing. Sorry, current through the inductor will start increasing. It will reach at point, then it will decrease. Okay, so during on period you will get a voltage, during off period you will not get voltage. Again during on period you will get a voltage. Okay, so when you take average of these, now input is Vs, say 200, and for some time your switch is off, so average output voltage is less than the input voltage. Okay. Okay, even though your duty cycle is to T on by T period is what I can say, means switch is continuously on, it is 1, then also the output voltage will be equal to Vs, not more than Vs. Okay, hence it is called as a step down chopper. Now what is its equation of output voltage? V0 equal to dVs, where D is a duty cycle. Okay, some people use instead D they use 10, some people use alpha. In your book PS Bimra they have used alpha here. Okay, so where D is the duty cycle, that is T on by T, and this is V0 average. But what is V0 RMS? It is under root D Vs. Okay, you may means in exam you may ask a numerical and you will have to solve on this. So let's see one numerical. This is a numerical from your book PS Bimra. So you can see terms like a 7.1 and all. So for a type B chopper, means for this particular chopper, DC source voltage equal to 230 volt. Okay, source voltage is given. Load resistance equal to 10 ohm. Now take a voltage drop of a 2 volt across chopper. Okay, this is an important point. If drop is not taken given, then directly you can consider V as a that given voltage, that is a 230. But as drop is given, we'll have to minus it. Okay, when it is on. For a duty cycle of 0.4, duty cycle is D is given. Calculate average and RMS values of output voltage and chopper efficiency. Okay, now when chopper is on, output voltage is actually it should be Vs, right? But it will not be Vs, it is Vs minus 2. Are you getting? And during the time chopper is off, output voltage is 0. Absolutely. So average output voltage will be what? We are having formula. Average output voltage is a D into input voltage Vs. So D is nothing but T on by T, which is given, that is 0.4. So here they have used symbol alpha. We have used D. So D 0.4 into C, D into Vs. So D, that is 0.4 into Vs. Vs is what? 230 volt. But actually 230 volt, no. There is a drop of 2 volt. So 230 minus 2. Okay. So we got 91.2 as a output voltage. You can compare that. Input is 230 volt and output is a 91. It is step down. Now RMS value of output voltage. What is the formula for RMS value? You can see it is under root D Vs. Okay. So don't look at this formula. You can, this is also formula, but they have reduced to there only where I have given under root D into Vs. Vs is 230 minus 2, so 144.2. This is the RMS value. Okay. Now next term is power output or power delivered to the load. What is the power delivered to the load? It is given as a V square by R. Simple formula. So V square, that is the RMS value, will be taken from here 144.2 square by R. So we will get 2079.364 watt. Now power input to the chopper. Power input is nothing but voltage into current. So voltage input voltage into that output current. Okay, so 230 into 91.2 divided by 10. Okay, why 10? Because we are consider this voltage average output voltage, because we are interested in a output current, right? So output current is a 91.2 divided by resistance, which is given here 10 ohm. So 91.2 divided by 10 ohm. Okay. This is the input power to chopper, no? So voltage is taken from input side and current is output current. So 230 into 91.2 by 10, that is the input power to the chopper. Now what is efficiency? It is output divided by input. Okay. So output is 2079.364. Input is 2097.6 into 100. So efficiency is a 99.33. Okay, so this is how we can solve the numerical on a step down chopper. Okay, I will once again just repeat. When switch is on, it will the supply will pass through inductor load